Look up tonight. Find a dark stretch of sky between the familiar stars, some quiet pocket of black where nothing seems to live. Hold your gaze there for a moment. What you're looking at isn't emptiness. It's a graveyard of light, a cemetery of galaxies that are still burning, still spinning, still full of planets and moons and perhaps even civilizations looking back in your direction, wondering about you. They exist. They're real, and you will never ever reach them. Not you, not your children, not the most advanced starship your species could ever build, not if you had 1 trillion years and every resource in the observable universe at your disposal. They're gone, not destroyed, not hidden, not blocked by some cosmic curtain we might one day pull aside. Gone in a more fundamental way than that. Gone because the space between you and them is growing faster than anything can cross it. Gone because the universe itself is pulling them away, stretching the fabric of existence at a rate that makes speed limits meaningless. Every second you sit here, roughly 5,000 more galaxies slip beyond the point of no return. Every year, approximately 160 billion stars cross a threshold from which no signal, no ship, no beam of light will ever return. That number again, 160 billion stars, every single year. And they don't explode, they don't wink out. They just quietly, gradually, imperceptibly recede into a forever we cannot follow. If these long, slow journeys into the strange architecture of existence help you drift off, or help you think, consider tapping that like and subscribe button. The algorithm notices and it helps others find their way here too. Now, let's begin. The observable universe is not the universe. This is the first and most important correction we need to make, and everything that follows depends on understanding it. When astronomers talk about the observable universe, they mean a sphere centered on Earth, with a radius of about 46 billion light-years. That sphere contains roughly 2 trillion galaxies, something like 200 billion trillion stars, more planets than there are grains of sand on every beach on Earth. It's unimaginably vast. It makes the entire history of human exploration look like an ant crawling across a single tile in a palace that spans continents. And it's a tiny fraction of what exists. The observable universe has a boundary, but that boundary isn't a wall. It isn't a surface. It's a horizon, like the horizon you see when you stand at the ocean's edge and look out at the water. There is more ocean beyond what you can see. You know this. The curvature of the Earth simply prevents you from seeing it. The cosmic horizon works differently, but the principle is similar. It marks the edge of what light has had time to reach us, given the 13.8 billion years since the Big Bang. Beyond that edge, there is more universe. Perhaps infinitely more. Perhaps just a lot more. We don't know. We can't know. Because the light from those regions hasn't had time to arrive. It's still travelling. It may never arrive at all. And here's where the strangeness begins to deepen. The universe is not just big, it's getting bigger. And not getting bigger at a steady pace, not expanding like a balloon inflating at a constant rate. It's accelerating. The expansion is speeding up. Every second, the rate at which distant galaxies recede from us increases. This acceleration has a name. Physicists call it dark energy. And that name tells you almost everything we know about it, which is almost nothing. It's dark because we can't see it. It's energy because it has to be something, some form of pressure or field or property of space itself that pushes everything apart. We can measure its effects with extraordinary precision. We can calculate exactly how fast the universe is expanding and exactly how fast that expansion is accelerating. But we have no idea what dark energy actually is, no idea where it comes from, no idea why it exists. We know that it makes up roughly 68% of the total energy content of the universe. We know that it behaves like a kind of anti-gravity, a repulsive force that acts on the larger scales, overwhelming the attractive pull of matter and radiation. We know that it's remarkably uniform, spread evenly throughout space, and that its density appears to remain constant even as space expands. And we know that it is, slowly and irreversibly, erasing the universe from our view. Stop and feel the weight of that for a moment. Not erasing the universe from existence, erasing it from our reach. There is a difference, and that difference is perhaps the cruelest part of the story. Let me try to give you a feel for what's actually happening, because the mechanism matters. The expansion of the universe is not like an explosion. It's not like galaxies flying away from some central point of detonation, debris scattering outward through pre-existing space. It's more like the space itself is stretching. Imagine a balloon with dots drawn on its surface. As you inflate the balloon, the dots don't move across the rubber, but they do move apart from each other because the rubber itself is expanding. Every dot sees every other dot receding. No dot is at the centre. Every dot is at the centre. The expansion is happening everywhere, all at once, at every point in the universe. Now imagine that the balloon is inflating faster and faster, not just expanding, but accelerating its expansion. The dots are moving apart from each other more quickly with every passing moment. And here's the critical insight. The farther apart two dots are, the faster they recede from each other. This is Hubble's law, discovered in 1929, refined ever since. The recession velocity of a distant galaxy is proportional to its distance. A galaxy twice as far away recedes twice as fast. But wait, if recession velocity increases with distance, then there must be some distance at which galaxies are receding from us at the speed of light. And beyond that distance, they must be receding faster than light. This seems impossible. Einstein told us nothing can travel faster than light. Hasn't this been drilled into us since childhood? The cosmic speed limit, the absolute boundary that nothing in the universe can cross. Yes and no. And here's where the universe reveals one of its most beautiful and most terrible loopholes. Nothing can travel through space faster than light, but space itself has no speed limit. Space can stretch as fast as it wants, and when space stretches fast enough, it carries galaxies away from us at velocities that exceed 300,000 kilometers per second, that exceed the speed of light, without any of those galaxies actually moving through their local space at all. They're sitting still relative to their surroundings. But their surroundings are flowing away from us. The river is moving. The boat is stationary on the river. But from our perspective, on our riverbank, the boat is receding impossibly fast. Einstein's rules stay intact. The cosmic fabric is the one breaking the speed limit. And this is not a technicality. This is not a philosophical distinction. This is the mechanism by which most of the universe has already become permanently unreachable. There is a number I need you to absorb, and I need you to absorb it slowly because it will change how you look at the night sky forever. 94%. That's the fraction of the observable universe's volume that is already gone. Not might become unreachable. Not is in danger of slipping away. Already gone. Permanently, irrevocably, forever beyond any possible contact. Every galaxy, currently more than about 18 billion light-years away, is receding from us faster than light. The photons leaving those galaxies right now, at this very moment, are travelling toward us at the fastest speed anything can travel, and they are still falling behind. The space between us and them is growing faster than they can cross it. They are swimming against a current that is too strong. They will never arrive. Let me put that in perspective. The observable universe has a radius of about 46 billion light-years. That means we can see light that has been travelling for nearly the entire age of the universe. Light that left its source 13 billion years ago or more. But that light left when the source was much closer to us. Since then, while the light was travelling, space has been expanding, and the source has been carried away. By the time the light finally arrives, the source is now 46 billion light-years away. Even though the light has only been travelling for 13 billion years, the expansion of space stretches the journey. Now here's the cruelty. We can see galaxies at 46 billion light-years. We can detect their light. We can study them. We know they exist, but we cannot reach them. By the time we even contemplate sending a signal or a ship in their direction, they are already receding faster than our signal or ship could travel. The image we're looking at is already a ghost, a photograph of something that has crossed the event horizon. You may have heard of event horizons in the context of black holes, the boundary around a black hole beyond which nothing, not even light, can escape. A point of no return. The universe has an event horizon too. It's not a surface you could touch. It's not a place you could visit. It's a distance, a threshold, a line in the sand of space-time. And everything on the other side of that line is gone. 94% of the observable universe is on the other side of that line. Stop and feel the weight of that. The 6% that remains, the fraction of the universe we might one day reach if we had unimaginable technology and unlimited time, isn't even the 6% we can see. This is another layer of the strangeness. Some of the galaxies we observe are still technically reachable, barely, if we left soon. Others we can see are already unreachable. The light arriving from them is ancient. And in the time since that light was emitted, they've been carried beyond the horizon. We're looking at their past selves, their younger selves, while their current selves exist in a realm we will never contact. It's like seeing someone's childhood photograph and knowing that the adult they became has already died, has already passed beyond any possible reunion. You can look at the photograph, you can study it, but you cannot meet the person. The universe is full of these ghosts, trillions of them, galaxies that were once part of our cosmic neighbourhood, in the sense that light could travel between us, that signals could be exchanged, that in principle a sufficiently advanced civilization could have visited or communicated. And now they're gone. Now they're just images. Memories inscribed in photons that will continue to redshift, to stretch, to fade, until eventually they drop below the threshold of detectability. And new galaxies are crossing the horizon every moment. Not in some dramatic fashion, not with any visible sign. They just quietly slip away. The photons they're emitting right now will travel for billions of years and never arrive. The civilizations that might live on planets orbiting their stars will never know we exist. We will never know they exist. Not because the distances are large, though they are. Not because the travel times are long, though they are, but because the universe itself has closed the door. This is what dark energy does. It doesn't destroy, it separates. It takes a universe that was once, at least in principle, a single connected whole, and it partitions it into forever isolated chambers, island universes, archipelagos of space-time that can never touch, never communicate, never know about each other, and we're on one of those islands, and our island is shrinking every year, every second. Perhaps you want numbers. Perhaps the scale of what I'm describing still feels abstract. Let me try once more to give you a feel for it. 160 billion stars per year. That's the rate at which stellar systems are crossing the cosmic event horizon. 160 billion every year. The Milky Way contains roughly 200 to 400 billion stars. So every year, the equivalent of half a Milky Way, or more, slips beyond the point of no return. Every 2 years, we lose a whole galaxy's worth of stars to the unreachable abyss. Every decade, 5 galaxies. Every century, 50. And this has been going on for billions of years, and it will continue for trillions more. The universe is 13.8 billion years old. For most of that time, the expansion was decelerating. Gravity was winning. The mutual attraction of matter was slowing down the expansion, pulling the brakes, giving us more time. But roughly 5 billion years ago, something changed. The density of matter had thinned out enough, and the influence of dark energy had grown strong enough that the balance tipped. The expansion began to accelerate. The brake pedal became a gas pedal. Since then, the universe has been speeding up, and it will continue speeding up forever as far as we can tell. Dark energy doesn't dilute as space expands. It stays constant, or perhaps even increases. Matter dilutes. Radiation dilutes. Gravity gets weaker as distances grow. But dark energy just keeps pushing, keeps stretching, keeps accelerating. 5 billion years ago, the universe began losing stars faster than light could keep up, and we have been aloning ever since. Picture yourself standing on a shore. The shore is our local group, the small cluster of about 50 or so galaxies that are bound to each other by gravity. The Milky Way is here. Andromeda is here, spiralling slowly toward us, destined to merge with the Milky Way in about 4.5 billion years. A few dozen smaller galaxies are here too, satellites and dwarfs, caught in our gravitational embrace. Beyond the shore, there is an ocean. The ocean is the rest of the cosmos. 2 trillion galaxies, 100 billion trillion stars, superclusters and voids and filaments of the cosmic web, structures so vast that the distance from one side to the other requires millions of years for light to cross. And the ocean is rising. No, that's not quite right. The ocean is pulling away, receding from the shore at an ever-increasing rate. The tide is going out, and it will never come back in. From your vantage point on the shore, you can see the ocean. You can see the glittering lights of distant islands, archipelagos of galaxies, whole continents of stars. You can study them through your telescopes. You can measure their light, their redshift, their composition. You can infer their histories, their masses, their futures. But you cannot swim to them. You cannot send a message that will reach them. You cannot even wave goodbye. because by the time your wave could arrive, they will have receded so far that the concept of arrival will have lost all meaning. And one by one, as you watch, the distant islands are dipping below the horizon. The farthest ones first, then the closer ones, then closer still. The ocean is retreating and the shoreline you stand on is becoming the only land left in existence. This is what will happen to the universe. This is what is already happening. Billions of years from now, when Andromeda has merged with the Milky Way to form some vast elliptical galaxy that future astronomers might call Milkomeda, when the sun has long since exhausted its fuel and the Earth is a frozen cinder, the sky will be different. Not just different in the way that skies change as stars are born and die, different in a more fundamental way. The distant galaxies will be gone, not destroyed, just invisible, red-shifted beyond detection. Their light stretched so thin, pushed so far into the radio spectrum, and then beyond the radio spectrum into wavelengths longer than the observable universe itself, that no instrument, no matter how sensitive, will ever detect them. The cosmic microwave background radiation, that faint echo of the Big Bang that tells us the universe was once hot and dense and young, will have redshifted away too. The evidence of the Big Bang will be undetectable. The proof that the universe once expanded will be invisible. Future astronomers, civilizations that arise billions of years from now, may look up at their sky and see only their own galaxy. They may conclude, reasonably and correctly based on the evidence available to them, that the Milky Way is the only thing that exists, that the universe is static, eternal, and local. They will have no way to know that there was once a rich, teeming cosmos full of 2 trillion galaxies. They will have no way to know that their ancestors could once see the evidence of cosmic expansion, of the Big Bang, of dark energy, of the true scale and history of existence. The evidence will be gone. The universe will have hidden its own past. Stop and feel the weight of that. We are alive at a privileged moment. This phrase is often used carelessly, thoughtlessly, as a kind of congratulatory pat on the back for existing. But in this context, it means something precise. We are alive in the brief window of cosmic history when the universe is still visible, still connected, still telling us its story. In the far past, the universe was too hot and too dense for light to travel. The cosmos was opaque, a searing plasma, photons scattering off free electrons billions of times per second. No structures had yet formed, no stars, no galaxies, no planets, just a blinding fog of radiation. In the far future, the universe will be too cold and too empty for light to arrive. The distant galaxies will have receded beyond the horizon. The cosmic microwave background will have redshifted into invisibility. The sky will be dark not because stars have died, though they will have, but because there will be nothing left to see. Between those two extremes, there is a window, a relatively brief window on cosmic timescales. A few 100 billion years, perhaps 1 trillion, when the universe is neither too hot nor too empty, when light can travel and structures can form and minds can emerge that are capable of looking up and understanding. We are in that window. We are alive in the golden age of cosmology. We can still see the Big Bang. We can still detect the cosmic microwave background. We can still observe galaxies at the edge of the observable universe. We can still measure the expansion rate, the acceleration, the dark energy that is slowly closing the door. And every second the window shrinks a little more. Every moment we spend not looking, not studying, not understanding, is a moment of potential knowledge lost forever. The universe is taking notes off the table. The evidence is being erased, and someday the erasure will be complete. You might ask whether this matters. You might ask why we should care about galaxies we can never visit, stars we can never touch, civilizations we can never meet. They were always impossibly far away. They were always beyond any practical reach. What difference does it make that they are now beyond any theoretical reach too? Here is one answer. It changes the meaning of the universe. If the cosmos was static, if distant galaxies stayed distant but reachable in principle, then the universe would be a single connected whole. Vast beyond comprehension, yes, but unified, coherent. A single room, even if the room had no visible walls. The light we see would be the only light there is. The matter we detect would be all the matter that exists. The cosmos would be ours to explore, given enough time, given enough technology, given enough ambition. But that's not the universe we live in. The universe we live in is fragmented. The The universe we live in is breaking apart. Not into pieces that shatter, but into pieces that drift, that recede, that fade. The light we see is not the only light there is. The matter we detect is a tiny fraction of the matter that exists. And most of that light, most of that matter, most of those galaxies and stars and planets, and perhaps civilizations, are already lost to us. This changes everything. It changes what it means to be curious, to seek knowledge, to explore. It means that no matter how much we learn, no matter how far we go, no matter how powerful our telescopes become, or how fast our ships might travel, we will never see more than a shrinking fraction of what exists. The universe is larger than we will ever know. Not larger than we can currently measure, larger than we can ever in principle measure. The boundary is not technological, it is physical. It is woven into the structure of space-time itself, and it changes what it means to be alone. We may not be alone in our local group. There may be other civilizations in the Milky Way, or in Andromeda, or in one of the dozens of smaller galaxies bound to us by gravity. Perhaps we will someday find them. Perhaps they will someday find us. The search for extraterrestrial intelligence is one of the great scientific endeavours of our age, and it is not hopeless. The distances within our local group are large but not infinite. Light can still cross them. Signals can still reach us. But the civilizations beyond our local group, the minds that may exist in the trillions of galaxies beyond our gravitational archipelago, we will never know. They may be looking up at their own skies right now, wondering if anyone is out there, sending signals into the void, hoping for a response, and their signals will never arrive, and our signals will never arrive, and we will live and die, and they will live and die, separated by a gulf that grows wider with every passing second, each of us alone in our own island universe, never knowing the other exists. That is what dark energy does. It doesn't destroy life, it isolates it. It takes a cosmos that might have been full of connection and communication and makes it into a vast prison, a network of solitary confinement cells, each one drifting farther from the others forever. Let me tell you what the universe looks like right now at this moment from the perspective of the physics. You are here. The Milky Way is here. About 2.5 million light-years away is Andromeda, the nearest large galaxy, close enough that in clear dark skies you can see it with your naked eye, a faint smudge of light. About 50 galaxies are close enough to us to be gravitationally bound, held together by mutual attraction despite the expansion of space. These galaxies will stay with us. They will merge with us. They will become part of our future, our shared destiny, our eventual descendants' home. Beyond that, the local group sits at the edge of the Virgo supercluster, a collection of thousands of galaxies spanning about 110 million light-years, and the Virgo supercluster is itself part of Laniakea, a vast complex of superclusters containing roughly 100,000 galaxies. But here's the crucial point. The Virgo supercluster and Laniakea are not gravitationally bound to us. They're too far away, too weakly connected by gravity, too separated by the expansion of space. The galaxies in these structures are currently moving away from us, and the acceleration of expansion is increasing that recession. Over billions of years, they will recede faster and faster. Their light will redshift, their images will fade, they will cross the cosmic event horizon, and we will be left with our 50 galaxies, our local group, our archipelago of stars in an infinite dark ocean. This is not speculation. This is not science fiction. This is the standard model of cosmology, refined over decades, tested by observations of distant supernovae and the cosmic microwave background and the large-scale structure of the universe. We know, to extraordinary precision, that the expansion is accelerating. We know that dark energy is real. We know that the future holds isolation. The details might change as we learn more. Perhaps dark energy isn't constant. Perhaps it will weaken over time, or strengthen, or do something unexpected. Perhaps new physics awaits that will revise our predictions. But the broad strokes are established. The universe is expanding, the expansion is accelerating, and most of what exists is already beyond our reach. The phrase cosmic event horizon deserves a moment of contemplation, because it is not a metaphor. It is a precise physical concept, as real as the event horizon of a black hole, as measurable as the distance to the moon. When you stand near a black hole, there is a surface called the event horizon. If you cross that surface, you cannot escape. No rocket, no thrust, no amount of energy will bring you back out. The curvature of space-time is so severe that every possible path forward leads deeper into the black hole. Escape is not merely difficult, it is geometrically impossible. The universe itself has been bent so that there is no out. The cosmic event horizon is similar but different. Instead of being caused by concentrated mass-bending space-time inward, it is caused by expansion stretching space-time outward. Instead of being a compact surface you could approach and study, it is a threshold defined by distance and recession velocity. Anything beyond a certain distance is receding from us faster than light. Anything we emit toward it will never catch up. Anything it emits toward us will never arrive. We cannot visit the cosmic event horizon. We cannot see it. We cannot mark it with a flag or a satellite. It exists everywhere, all around us, at the edge of the reachable universe, and it is moving closer. Not because the horizon itself is shrinking, but because the amount of universe inside the horizon is growing more slowly than the amount of universe outside. Every year, more galaxies cross the line, more stars slip beyond reach. The ratio shifts, the isolation deepens, and there is nothing we can do to stop it. I want to be careful here. I want to be precise about what is lost and what remains. Because this story is not a story of pure despair. It is a story of perspective, of humility, of the strange privilege of being alive in a universe that reveals its own architecture even as it hides its own edges. What remains is still vast beyond comprehension. The local group alone contains hundreds of billions of stars. If there are habitable planets around even a tiny fraction of those stars, the number of potential worlds is enormous. The merging of the Milky Way and Andromeda will create a galaxy larger than either, with trillions of stars, with star formation continuing for billions of years, with time enough for civilizations to rise and fall, and rise again millions of times over. What remains is not nothing. What remains is still more than we can explore in the entire remaining lifespan of the Sun, more than we can understand in 1,000 generations, more than we can imagine in our wildest cosmic ambitions. But what is lost, what is being lost, what will continue to be lost with every passing moment, is the rest, the 94%, the 2 trillion galaxies that are already ghosts, the civilizations that might exist out there, looking up at their own skies, dreaming of connection, separated from us by a gulf that grows wider with every tick of the cosmic clock. They are gone, they are not coming back. And somewhere out there, perhaps, intelligent beings are watching us recede beyond their horizon, watching the Milky Way fade to invisibility, wondering who we were, whether we were curious, whether we ever thought about them. We will never know, and that is perhaps the strangest truth of all. Not that the universe is vast, not that we are small, but that most of the universe exists right now, burning and spinning and perhaps even thinking, and we are permanently cut off from it. Not by distance alone, not by time alone, but by the structure of existence itself. The structure of existence itself. Let that phrase settle for a moment. Because what I've described so far, the cosmic event horizon, the galaxies slipping away, the permanent severance, these are not metaphors. They are not poetic interpretations. They are physical facts, as measurable as the distance to the nearest star, as real as the light entering your eyes right now. But to truly feel the weight of this, we need to go deeper. We need to understand not just that the universe is receding, but why. What is the force driving this expansion? What is the thing pushing the cosmos apart? The answer is dark energy. And the truth about dark energy is stranger than almost anything else in physics. Here is what we know. The universe is expanding. We've known this since Edwin Hubble's observations in the 1920s, when he noticed that distant galaxies are moving away from us, and the farther they are, the faster they're moving. This was a revolution. For thousands of years, humans assumed the cosmos was static, fixed, a crystalline sphere of eternal stars. Hubble showed us that the universe is dynamic. It is growing. Space itself is stretching. But here is what we discovered in 1998, what earned 3 physicists the Nobel Prize, what overturned nearly every expectation cosmologists had built up over decades of careful work. The expansion is not slowing down, it is speeding up. Think about what this means. Imagine you throw a ball straight up into the air, gravity pulls on it, it slows, it reaches a peak, it falls back down. Now imagine you throw the ball and instead of slowing, it accelerates away from you. Faster and faster, against gravity, against everything pulling it back. That would require some unseen force, some invisible push, some energy you cannot detect but whose effects you can measure. That is what is happening to the universe. Every galaxy in the cosmos is like that ball. Gravity pulls them together. The mutual attraction of all the matter in the universe should be decelerating the expansion, slowing the cosmic stretching, perhaps even bringing everything back together in a great reversal. But instead, the expansion is accelerating. Something is pushing. Something is winning against gravity on the largest scales. We call that something dark energy. And we know almost nothing about what it actually is. The numbers here are humbling. Dark energy comprises approximately 68% of the total energy content of the universe. Ordinary matter, the atoms that make up you, me, planets, stars, every physical object we have ever touched or seen or measured, constitutes about 5%. Dark matter, the invisible gravitational scaffolding that holds galaxies together, makes up about 27%. And the remaining 68%, the majority of everything that exists, is dark energy. 2/3 of the universe is made of something we cannot see, cannot touch, cannot directly detect, and cannot explain. Let me try to give you a feel for how strange this situation is. Imagine you are a detective investigating a crime scene. You've gathered every piece of evidence, you've interviewed every witness, you've reconstructed the sequence of events with painstaking precision. But when you step back and look at your reconstruction, you realise that 68% of the crime happened in a room you cannot enter, was committed by a suspect you cannot identify, using a weapon that leaves no fingerprints and no trace. You know it happened. The evidence of its effects is everywhere. But the thing itself is invisible to every instrument you possess. That is where cosmology stands today. The effects of dark energy are unmistakable. We can measure the acceleration of the expansion. We can trace how galaxies have receded over billions of years. We can detect the signature of dark energy in the cosmic microwave background, the afterglow of the Big Bang. We can model its influence on the large-scale structure of the cosmos with remarkable precision. But when we ask what dark energy actually is, the honest answer is that we do not know. The simplest model, the one that fits the observations best, is called the cosmological constant. It is a term in Einstein's equations of general relativity, a property of space itself. According to this model, empty space has an intrinsic energy density. A cubic metre of void, even if it contains nothing at all, as no particles, no radiation, no fields, still possesses a tiny amount of energy. And this energy exerts a repulsive gravitational effect. It pushes space apart. This sounds reasonable enough until you ask where this energy comes from. And there, at the foundations, we encounter one of the most embarrassing failures in the history of theoretical physics. Quantum mechanics tells us that empty space is not truly empty. Even a perfect vacuum seethes with quantum fluctuations, virtual particles popping in and out of existence, fields vibrating at their lowest possible energy states. These fluctuations carry energy. We can calculate this energy using the principles of quantum field theory, and when we do the calculation we get a number. The number is wrong by a factor of approximately 10 to the power of 120. Say that slowly. 10 to the 120. A 1 followed by 120 zeros. This is not a small discrepancy. This is not a factor of 2, or a factor of 1,000,000, or a factor of 1,000,000,000,000. This is the largest mismatch between theoretical prediction and experimental observation in the entire history of physics. If you predicted the weight of a grain of sand and got a number heavier than 1,000,000,000,000,000,000,000,000 universes, you would have made a comparable error. The calculation says that empty space should be saturated with vacuum energy, so dense that it would have ripped the universe apart in the first fraction of a second after the Big Bang. Or, if the energy were negative rather than positive, it would have collapsed everything into a single point before the first star could form. The universe should not exist in anything like its present form. And yet here we are. The cosmological constant has the value it has, small enough for galaxies to form, large enough to drive the observed acceleration, and nobody knows why. This is called the cosmological constant problem, and after decades of work by the most brilliant physicists on Earth, it remains unsolved. Some researchers have suggested that dark energy might not be constant at all. Perhaps it varies over time, perhaps it is some kind of dynamical field, dubbed quintessence by those who named it, slowly evolving as the universe ages. If dark energy is not truly constant, if its properties change over cosmic time, then the future I've described might unfold differently. The expansion might accelerate more quickly, or more slowly, or even reverse. But current observations suggest that if dark energy is varying, it is doing so extremely gradually. The cosmological constant model fits the data. The mystery remains. Let me offer another way to feel the strangeness of this. Consider the energy density of dark energy. In natural units, it is roughly 10 to the minus 47 electron volts to the fourth power. This is an unimaginably tiny number per cubic meter. A billionth of a billionth of a billionth of the energy density of ordinary matter under familiar conditions. In any laboratory, in any particle accelerator, on any scale we can probe directly, this energy density is completely negligible. It has no detectable effects whatsoever. But sum it up across the vastness of space, across billions of light years, across the unthinkable volume of the observable universe, and this tiny energy density comes to dominate everything. Dark energy wins not by being strong in any one place, but by being everywhere, relentlessly, uniformly pushing in every cubic meter of emptiness throughout the cosmos. This is perhaps the deepest strangeness. Dark energy is weak beyond measurement on small scales, but on the larger scales, it is the most powerful force in the universe. It is reshaping existence. It is determining the fate of all structure, all life, all possibility. And it operates so subtly that for most of cosmic history, no one could have detected it at all. The discovery of dark energy in 1998 came from observations of distant supernovae. Type Ia supernovae are a special class of stellar explosion. They occur in binary star systems, when a white dwarf, the collapsed remnant of a sun-like star, accumulates matter from a companion until it reaches a critical mass and detonates in a thermonuclear blast. These explosions are remarkably uniform. They all release approximately the same amount of energy. They all have approximately the same intrinsic brightness. This makes them what astronomers call standard candles, objects whose true luminosity is known, so that their distance can be inferred by how dim they appear. Two independent research teams, the Supernova Cosmology Project and the High Z Supernova Search Team, set out in the 1990s to use these distant explosions as mile markers. Their goal was to measure how the expansion rate of the universe was changing over time. They expected to find deceleration, gravity slowly winning, the expansion gradually slowing. What they found instead was the opposite. Distant supernovae were dimmer than expected. They were farther away than a decelerating universe would allow. The expansion was speeding up. The announcement came in 1998. By 2011, Saul Perlmutter, Brian Schmidt, and Adam Rees had been awarded the Nobel Prize in Physics for the discovery. And the field of cosmology had been transformed. Dark energy entered the standard model of cosmology. It became one of the three pillars, along with dark matter and ordinary matter, that determine the structure and fate of the universe. And it presented physicists with a puzzle that remains unsolved to this day. Let me describe what this puzzle looks like from the inside. Imagine you're a theoretical physicist in 1997. You have spent your career working on the equations of general relativity and quantum field theory. You understand that vacuum energy is a prediction of quantum mechanics. You understand that it should contribute to the cosmological constant. But you also know that the naive calculation gives an absurd answer. So you assume there must be some mechanism, some symmetry, some cancellation, some deeper principle that sets the cosmological constant exactly to zero. This has been the working assumption for decades. The cosmological constant is zero, and your job is to figure out why. Then the supernova data arrives. The cosmological constant is not zero. It is small, astonishingly, preposterously small compared to the naive quantum prediction. But it is not zero. It has precisely the value needed to dominate the universe at this moment in cosmic history, to begin accelerating the expansion about 5 billion years ago, to reshape the future in exactly the way I have described. Why that value? Why not zero? which would at least be elegant? Why not enormous, which is what the quantum calculation suggests? Why this particular number, sitting at the edge of detectability, fine-tuned to a precision that makes no theoretical sense? Some physicists have turned to the anthropic principle. Perhaps, they suggest, the cosmological constant varies from place to place across a vast multiverse. In most regions, it is either too large, ripping space apart before galaxies can form, or too negative, collapsing everything into oblivion. Only in rare patches, where the cosmological constant happens to take a hospitable value, can structure form, life evolve, and observers like us exist to ask the question. We measure the value we measure because any other value would have prevented our existence. This explanation is deeply unsatisfying to many. It feels like giving up. It invokes an unobservable multiverse to explain what we cannot derive from first principles. It trades one mystery for another, and yet, after decades of searching, no better explanation has emerged. The cosmological constant problem remains the single most glaring unresolved issue at the intersection of quantum mechanics and gravity. Perhaps the answer lies in a theory we have not yet discovered. String theory, loop quantum gravity, and other candidates for a theory of quantum gravity might one day explain the value of the cosmological constant. Perhaps there is a mechanism, as yet unknown, that dynamically selects the value we observe. Perhaps the answer is stranger than anything we have imagined. A clue hiding in plain sight, waiting for some future physicist to see it clearly. But for now, we must proceed with what we know. And what we know is that dark energy exists, that it comprises most of the universe, that it is accelerating the expansion, and that this acceleration is carrying the cosmos beyond our reach. The effects are not subtle. They are measurable. They are happening right now as you listen to these words. Consider a galaxy sitting at the edge of our cosmic event horizon. Light from that galaxy, emitted today, is racing toward us at 300,000 kilometers per second. But space between us and that galaxy is stretching. The galaxy is receding. And because the expansion is accelerating, the recession velocity is increasing with every passing moment. The light struggles forward. The distance it must cross grows longer. Year by year, the photons fall behind. They make progress in a sense. They travel through space at the maximum possible velocity. But the finish line is moving away faster than they can run. Eventually, the light simply gives up. It never arrives. It becomes part of the unreachable cosmos, separated from us by an expanding gulf that no signal can ever cross. And this is happening everywhere, in every direction, at every moment. Let me give you a number. Approximately 20,000 stars cross the cosmic event horizon every second. 20,000 suns, slipping beyond the edge of possibility, becoming permanently isolated from everything that we are and everything that we might become. Not because they are moving through space, not because some catastrophe has befallen them, simply because space itself is stretching too fast for any connection to persist. Over the course of a human lifetime, let us say 80 years, roughly 50 trillion stars will have crossed that threshold. 50 trillion suns, 50 trillion potential solar systems, 50 trillion sites where life might have evolved, where minds might have awakened, where beings might have looked up at their own skies and wondered what lay beyond. Gone, not destroyed, not ended, just unreachable, forever. And the process will continue. It is not slowing. It is accelerating. The rate at which we lose the universe will only increase as time goes on. The cosmic loneliness is not a static condition. It is deepening. It is intensifying. With every breath you take, the walls close in a little further. I want to sit with this for a moment. I want to let the scale of it settle into your awareness. Most of what exists is already beyond our reach, and most of what we can still see will follow, given enough time. The great burning galaxies, the clusters and superclusters that light up the cosmic web, the unimaginable diversity of stars and worlds and possible histories, all of it is receding, fading, sliding toward the unreachable. We are on an island, the ocean is rising, and there is no higher ground. And yet, here is the thing I keep returning to. The thing that prevents this from being a story of pure despair. We know. We have figured this out. A species on a small planet around an ordinary star in an unremarkable corner of an unexceptional galaxy has worked out the structure of the cosmos. We have measured the acceleration. We have detected the dark energy. We have calculated the horizons, we have understood what is being lost and why. This knowledge does not change the fate. Nothing we do will bring back the galaxies that have already crossed the threshold. Nothing we build will ever reach the 94% that is already gone. But the knowledge itself is remarkable. The fact that the universe is structured in such a way that beings like us can arise, ask questions and receive answers, that is not nothing. That is something to hold on to, because the universe is not obligated to be comprehensible. It is not obligated to reveal itself. There is no cosmic law that says pattern-seeking primates on a wet rock should be able to deduce the fate of creation from the redshift of distant explosions. And yet here we are, knowing. The galaxies slip away, the stars vanish beyond horizons we cannot approach. The future grows lonelier with every passing second. But the understanding remains. The picture emerges. The story is being told. We are not merely witnesses to the closing of the cosmic book. We are readers who have learned to decipher a few of its pages before they fade. And that, in its own strange way, is a kind of triumph against the indifference of the void. Dark energy does not care that we understand it. The accelerating expansion has no interest in our theories, our observations, our Nobel Prizes. It will continue doing what it does whether or not anyone is watching. But we are watching. And we will keep watching for as long as eyes remain open and instruments keep gathering light. We will measure the loss, we will track the recession, we will document the emptying, and when future astronomers, billions of years from now, look up at a sky containing only the merged remnants of the local group, perhaps they will still have records, ancient databases passed down through unimaginable spans of time, telling them what the universe once looked like. Telling them that there were once 2 trillion galaxies. Telling them that there was once a cosmic web of light stretching in every direction. They will have to take it on faith. They will not be able to see it for themselves. The evidence will be gone, red-shifted to wavelengths so long that no instrument could detect them, or simply never arriving at all. But if our records survive, if some chain of transmission persists across the eons, then knowledge will remain even after observation becomes impossible. The universe will have hidden itself. But we will remember what was lost. That too is a kind of victory, small perhaps, cold comfort against the scale of the vanishing, but real, human, ours. The expansion continues, the darkness deepens, and somewhere out there, beyond the horizon we can never cross, galaxies burn in silence, spinning and living and perhaps even thinking, forever separated from us by the stretching of space itself. We have been speaking of horizons and what lies beyond them. We have been speaking of loss on a cosmic scale, of galaxies sliding into unreachable darkness, of the slow dimming of a universe that was once briefly visible in its fullness. But now I want to take you somewhere different. I want to take you inside the numbers themselves, because the numbers are where the vertigo lives. Let me try to give you a sense of what 94% actually means. Picture the observable universe as a sphere. You're at the centre, not because you're special, but because the observable universe is defined by your position. It is the bubble of space from which light has had time to reach you since the beginning. From any other location, the sphere would be centered there instead, but the size would be the same, roughly 93 billion light-years across. That is the diameter of everything we can in principle see. Now imagine you could somehow freeze time and take a census. You send out impossibly fast surveyors to count every galaxy, every star, every world. They report back approximately 2 trillion galaxies, perhaps more, depending on how you count the smallest ones, the faint dwarf galaxies lurking in the cosmic shadows. 2 trillion collections of hundreds of billions of stars each. The number of stars in the observable universe is something like 2 times 10 to the 23rd power. That is 200 sextillion. That is more stars than grains of sand on every beach on Earth. And 94% of that volume is already beyond our reach. Not hidden, not destroyed, not blocked by dust or gas or some intervening structure. Simply receding too fast for causality to connect us. The light from those regions is still travelling, still dutifully attempting to close the gap, but the gap is growing faster than the light can cross it. The messengers are running, but the road is stretching beneath their feet. They will never arrive. When I say 94%, I do not mean 94% of the interesting stuff. I do not mean 94% of the boring empty regions between galaxies, while we keep the rich and populated cores. I mean 94% of everything, uniformly distributed, statistically identical to the 6% we can still theoretically access. Whatever the accessible universe contains, every type of galaxy, every category of star, every possible configuration of matter and energy and perhaps life. The unreachable regions contain all of that too, in similar proportions, just vastly more of it. If there are other civilizations out there, most of them are already beyond the horizon. If there are planets with liquid water and complex chemistry and evolution running its endless experiments, most of those planets are in the 94%. If the universe has secrets we have not yet discovered, exotic structures or phenomena we cannot currently imagine, most of those secrets are locked away in regions we will never access. Stop and feel the weight of that. We often speak of the universe as though it belongs to us, as though we are its rightful heirs, destined to spread across the stars and claim some grand cosmic inheritance. But the inheritance has already been distributed. We are left with the scraps, magnificent scraps to be sure, billions of galaxies within our accessible range, countless worlds to explore if we ever develop the technology, but scraps nonetheless, 6% of what exists, 6% of what was ever possible, and it is getting smaller. Let me walk you through the mathematics of the loss. Not the abstract version, but the visceral one. Every second, the cosmic event horizon, the boundary between what is still theoretically reachable and what has slipped forever beyond our grasp, creeps inward by approximately 18 kilometers. That does not sound like much. 18 kilometers is about the length of Manhattan Island. You could walk it in a few hours, but this is not a one-time loss. This is continuous. Every second that passes, another Manhattan-length shell of space transitions from accessible to inaccessible. Every minute, every hour, every year, the shrinking continues. Over the course of a single human lifetime, say 80 years, the accessible universe contracts by a volume containing roughly 400 billion stars. 400 billion. That is more stars than the entire Milky Way galaxy. Every human lifespan, we lose a galaxy's worth of potential destinations, not because the stars have died, not because they have exploded or collapsed or been swallowed by black holes, simply because the expansion of space has pushed them past the point of no return. Every year, approximately 160 billion stars cross the horizon. Let me say that differently. In the time it takes Earth to complete a single orbit around the Sun, 160 billion suns, most of them surrounded by planets, many of those planets probably capable of harbouring something, become forever inaccessible. That is roughly 5,000 stars per second. 5,000 signals extinguished every heartbeat. 5,000 campfires winking out at the edge of the wilderness, not because their fuel ran out, but because the darkness between us and them grew too wide to cross. And there is nothing we can do about it. No technology we can imagine, no violation of physics we might hope for will change this. Even if we built ships that travelled at 99% of the speed of light, we could not catch the galaxies that have already crossed. Even if we discovered some loophole, some wormhole or warp drive or bending of space-time that allowed faster-than-light travel, something that almost certainly does not exist, something that would require physics we have no reason to believe is real, it would not help with the galaxies that are already gone. Their light is still reaching us, still carrying ancient images of their former selves, but those images are postcards from a place we can never visit. The galaxies themselves have moved on. They are beyond any bridge we could build. This is what exponential loss looks like when stretched across cosmic time. Today, the observable universe is large enough to contain 2 trillion galaxies. In 100 billion years, a span of time almost 7 times longer than the current age of the universe, the accessible universe will contain only our local group, a cluster of perhaps 50 galaxies gravitationally bound together tightly enough to resist the expansion. Everything else will be gone, not hidden behind some temporary veil, not waiting to be rediscovered. Gone in the most absolute sense that cosmology allows. The universe will look empty. Future astronomers, members of whatever species or intelligences might exist in that unimaginably distant era, will peer outward with whatever instruments they possess and see nothing. Darkness in every direction, stretching to infinity. They might assume that the local group is the entire cosmos, a small cluster of stars burning in an otherwise empty void. They would have no reason to suspect otherwise. No evidence would remain. Think about what that means for the enterprise of knowledge itself. Science depends on observation. We can only study what reaches us: light, gravitational waves, particles, some form of signal from the external world. If the signals never arrive, the phenomena that generated them become unknowable. Not just unknown in the sense that we have not yet figured them out, but unknowable in principle, forever beyond the reach of investigation. The future universe will be a universe where cosmology as we practice it is impossible. Future scientists will be unable to discover the cosmic microwave background radiation, that faint afterglow of the Big Bang that has taught us so much about the early universe. It will have redshifted to wavelengths so incredibly long that no detector could register them. They will be unable to measure the expansion of space, because there will be nothing left beyond the local group to observe expanding away. They will be unable to detect the signatures of distant supernovae, the standard candles we use to map the universe's acceleration. The candles will have burned beyond the horizon. In essence, the evidence for the Big Bang itself will have vanished. Let that sink in. The most fundamental facts about our universe: that it began in a hot, dense state 13.8 billion years ago, that it has been expanding ever since, that the expansion is accelerating, that there were once 2 trillion galaxies where now only dozens remain. All of this will be undetectable to future observers. They will live in a cosmos that has erased its own history. The universe will have become a mystery to itself, a book that has burned most of its pages while pretending they never existed. We happen to live in the narrow window when the pages are still legible. This is not a minor cosmic coincidence. This is not like happening to witness a particular eclipse or meteor shower. This is the difference between being able to comprehend the entire structure of reality and being condemned to permanent ignorance of almost everything that exists. We are witnesses to a universe in transition, a universe that is actively destroying the evidence of its own nature. In cosmological terms, we have arrived just in time, but only just. Now, I want to take you somewhere stranger still. I want to show you why this loss is not merely about distance, but about the fundamental structure of causality itself. When physicists speak of the cosmic event horizon, they are borrowing a term from black hole physics. Around a black hole, there is a surface beyond which nothing can escape. Not light, not matter, not information of any kind. Cross that boundary and you are gone, cut off from the outside universe, unable to send any signal back. The cosmic event horizon works similarly, but in reverse. We are not falling into something. Instead, the universe beyond the horizon is falling away from us, accelerating outward at speeds that make any connection impossible. Here is what makes this so disorienting. The galaxies beyond the horizon still exist. They are still burning, still spinning, still doing whatever galaxies do. Perhaps civilizations are rising and falling on worlds we will never see. Perhaps there are phenomena out there, structures or processes or cosmic events, that would revolutionize our understanding of physics if only we could observe them. But we cannot, and we never will. Not because they are hidden, but because the fabric of space-time has been stretched past the breaking point of causality. In every meaningful sense, those regions have become separate universes. Think about what it means for something to be in your universe. It means you can, in principle, be affected by it. Light from a distant star can reach your eyes. A gravitational wave from a merging black hole can ripple through your body. Information can flow from there to here, even if it takes billions of years to arrive. These causal connections are what knit the cosmos into a single unified whole. Without them, there is no shared reality. There is only isolated pockets of existence, each one cut off from all the others. The cosmic event horizon is the surface where those causal connections are severed forever, and the horizon is everywhere. It is not a wall in space that you could approach if you travelled far enough. It is a boundary in space-time, a limit defined by the geometry of an accelerating expansion. No matter where you are in the observable universe, you have your own horizon, and it is doing the same thing. Contracting, shrinking, cutting off more and more of what was once accessible. If there are observers in those distant, now unreachable galaxies, they see a similar picture from their perspective. To them, we are the ones who have receded beyond the horizon. We are the ones who have become forever inaccessible, just as they have become inaccessible to us. Both perspectives are equally valid. Both are correct. The universe does not have a preferred frame of reference, a special vantage point from which the true picture can be seen. There are only different horizons, different spheres of accessibility, each one shrinking in its own local frame. The cosmos is fragmenting into isolated bubbles, each one believing itself to be alone. And here is perhaps the strangest thing of all. The expansion does not stop at any boundary. Space does not end where our horizon ends. Beyond the cosmic event horizon, there is more space, more galaxies, more stars, more matter and energy, almost certainly infinitely more. The observable universe, vast as it is, may be only an infinitesimally small fraction of the total cosmos. There could be regions stretching beyond any limit we could imagine, containing structures and phenomena we have no framework to predict. But we will never know. Not because we are limited by technology, not because we have not tried hard enough or thought cleverly enough. We will never know because the geometry of space-time itself has made knowing impossible. The information from those regions cannot reach us. It is travelling toward us at the speed of light, but it is losing ground, falling further behind with every moment. The gap between messenger and destination is growing faster than any signal can bridge. This is not a failure of physics. This is what physics predicts. The equations are clear. The observations confirm them. The universe is structured in such a way that most of it is permanently cut off from the rest. This is not a bug in the cosmic code. It is a feature. A cold, indifferent feature that cares nothing for our desire to explore, to connect, to understand. We're used to thinking of the universe as vast but navigable, as an ocean that is large but still continuous, still crossable given enough time and effort. That picture is wrong. The universe is more like an archipelago of shrinking islands, each one slowly becoming isolated, each one watching the other islands sink below the horizon. The ocean is not water. It is space itself, and it is rising. Now, let me show you what this means for the question that haunts us most. If there is other intelligent life in the cosmos, where is it? This question, sometimes called the Fermi paradox after the physicist who asked it over lunch one afternoon in 1950, has generated endless speculation. Perhaps life is rare. Perhaps intelligence is rarer still. Perhaps technological civilizations inevitably destroy themselves. Perhaps we are among the first. Perhaps we are alone. But dark energy adds another possibility, one that is both comforting and devastating. Perhaps they are out there. Perhaps they are everywhere. Perhaps the universe is teeming with civilizations, some unimaginably ancient and advanced, some just beginning their journey into consciousness. Perhaps the cosmic web contains countless pockets of intelligence, each one asking the same questions we ask, each one looking up at a darkening sky and wondering who else might be out there. And perhaps we will never meet any of them. Not because the distances are too great, although they are. Not because interstellar travel is too difficult, although it is. But because the expansion of space is pulling us apart faster than any signal can connect us. The civilizations that might exist in the 94% that is already beyond our horizon are gone. They could be building empires that span thousands of galaxies. They could have solved every problem that still confounds us, from the nature of consciousness to the unification of fundamental forces. They could have answers to questions we have not yet learned to ask. It does not matter. We will never hear from them. They will never hear from us. The horizon has closed between us, and no force in the universe can open it again. Even within the accessible 6%, time is running out. Every year, 160 billion more stars slip beyond the reach of any signal we could send. If there are civilizations in those star systems, they are being cut off one by one, like ships disappearing over the horizon of an endless sea. Each departure is final. Each farewell is forever. The window for cosmic contact is closing. We do not know how wide the window is. We do not know how much time remains before the civilizations that might exist within our reach have themselves slipped beyond it. Perhaps millions of years, perhaps billions. But whatever the number, it is finite, and it is shrinking. If we are ever to make contact with other intelligence, we must do so before the expansion makes contact impossible. This adds a strange urgency to the question of whether we are alone. It is not merely an intellectual puzzle, not merely a curiosity to satisfy. It is a race against the cosmic clock. The universe is emptying. The opportunities are diminishing. If we wait too long, there will be no one left to find. And even if we do find someone, even if we detect a signal, a message, some unmistakable proof that we are not alone, we may never be able to respond. By the time we decipher the message and compose a reply, the civilization that sent it may have crossed the horizon. Our answer would travel outward forever, never arriving, never being heard. This is the loneliness that dark energy imposes on any would-be cosmic explorer. It is not just that the universe is large. It is that the universe is accelerating away from itself, tearing its own fabric into disconnected patches, isolating every observer within an ever-shrinking sphere of accessibility. Even if the cosmos is rich with life, even if intelligence is as common as stars, the expansion ensures that most of it will never know about the rest. We are not just searching for neighbours in a vast neighbourhood, we are searching for lifeboats on a fragmenting sea, each one drifting away from all the others, each one destined to spend eternity alone. But here, in this narrow window of cosmic history, a few lifeboats can still see each other. A few signals can still cross the gap. A few connections are still possible. We should not waste the moment, because this is what makes our situation so strange, so poignant, so charged with meaning. We are alive at the only time when the cosmos is both old enough to produce intelligence and young enough to still be visible in its fullness. 1 billion years ago, the universe was even richer, even more connected, but there was probably no one here to see it. 100 billion years from now, there may still be intelligence, but it will be trapped in a local group that has forgotten the rest of the universe ever existed. We are the in-between, the witnesses, the accidental heirs of a cosmic moment that will never come again. The expansion continues, and what it carries away is not merely distance, it carries away possibility itself. Every photon that crosses the horizon takes with it a universe of stories we will never read, questions we will never answer, beauty we will never see. The loss is total, the loss is permanent, and the loss is accelerating. But to understand what we are losing, we must first understand what we still have. We must look carefully at the shrinking bubble of cosmos that remains accessible, the diminishing island of light and matter that future generations will inherit. Because even this remnant, this 6%, this thin slice of everything that once was, even this is larger and stranger than most minds can hold. The observable universe today spans roughly 93 billion light-years from edge to edge. That measurement sounds impossibly large, and it is. But hidden inside that number is a subtlety that changes everything. The universe we can see is not the same as the universe we can reach. Light travels at a fixed speed, 186,000 miles per second, and nothing with mass can exceed that limit. But space itself has no such constraint. Space can expand faster than light, and in the accelerating cosmos driven by dark energy it does. The result is a fracturing of observation from possibility. We can still see galaxies that we can never touch. We can still receive light that left its source when the universe was young, when those sources were close enough to reach, when the cosmos was still connected, but the sources themselves have long since crossed into the unreachable beyond. This creates a strange layered structure in our cosmic neighbourhood. There is the observable universe, everything whose light has had time to reach us. There is the reachable universe, a much smaller volume containing only those destinations a spacecraft could still reach if it left today. And there is the already lost universe, the vast emptiness between the observable and the reachable, filled with galaxies we can photograph but never visit. The boundary between reachable and unreachable is called the cosmic event horizon. It sits today at roughly 16 to 18 billion light-years away, depending on which assumptions you use and how you handle the uncertainties in the cosmological parameters. That number will confuse you if you think about it too hard. The observable universe extends 46 billion light-years in every direction, which means we can see objects 3 times farther away than we can ever reach. The light from those distant galaxies is still trickling in, carrying images of what they looked like billions of years ago. But the galaxies themselves have long since accelerated beyond any possibility of contact. They are ghosts. They are light without substance. They are postcards from a place that no longer exists in any meaningful sense. And here is the part that makes cosmologists uneasy. The cosmic event horizon is not fixed. It is not a wall that sits at a certain distance and stays there. It is shrinking. It is creeping inward. Not rapidly, not dramatically, but steadily, relentlessly, with all the patience of deep time. Every year, galaxies that were reachable become unreachable. Every year the volume of accessible space contracts. Every year the shrinking accelerates slightly as dark energy tightens its grip on the expansion. Let me put that in perspective. Right now, if you launched a spacecraft from Earth at the maximum theoretically possible speed, if you somehow accelerated to 99.9999% of the speed of light and maintained that velocity for billions of years, you could in principle reach destinations up to about 16 billion light years away. That sounds enormous. It is enormous. But it is less than 40% of the observable universe by radius and far less than 40% by volume. The cube of that fraction means that even at the theoretical maximum, even ignoring every practical barrier, even granting physics that borders on magic, you could never access more than about 6% of the galaxies you can currently see. And that 6% is shrinking. A billion years from now, the event horizon will have contracted. The accessible volume will be smaller. 100 billion years from now, only the gravitationally bound structures, the Milky Way, Andromeda, the other members of our local group, will remain within reach. Everything else will have crossed the horizon. The great clusters of galaxies that we observe today, the filaments and walls of the cosmic web, the superclusters that span hundreds of millions of light years, all of it will be gone. Not destroyed, just forever beyond reach. The shrinking is not linear. It follows a subtle curve dictated by the interplay between the universe's matter content, which pulls things together, and its dark energy content, which drives things apart. In the early universe, matter dominated, and the expansion was decelerating. Gravity was winning, slowing the stretching of space, keeping distant regions accessible for longer. But roughly 5 to 6 billion years ago, dark energy began to dominate. The expansion shifted from decelerating to accelerating. The cosmic event horizon, which had been growing outward as the universe aged, stopped growing and began to shrink. We crossed a threshold without knowing it. We entered the era of cosmic isolation without sending a single probe beyond our own solar system. That transition, that shift from deceleration to acceleration, was perhaps the most significant event in cosmological history since the Big Bang itself. It marked the moment when the universe changed character, when the promise of an ever larger accessible cosmos gave way to the certainty of an ever smaller one. Before that transition, waiting was an advantage. The longer you waited, the more universe you could reach because the horizon was expanding faster than space-time was stretching beyond it. After the transition, waiting became a cost. Every moment of delay meant fewer destinations, fewer stars, fewer possible neighbours. The cosmic clock reversed. We crossed that threshold roughly when the Earth was forming, 4.5 billion years ago, as our planet was coalescing from dust and gas around a young sun. The universe was quietly pivoting from an era of possibility to an era of loss. Life on Earth evolved entirely within the age of acceleration. Every creature that has ever drawn breath on this planet has lived in a universe that was contracting around it, shrinking the accessible cosmos one galaxy at a time. We never knew a different kind of universe. We never experienced the era when the horizon was growing, when the cosmic library was adding shelves faster than we could build ladders to reach them. We were born into the autumn of accessibility, and we are living through its slow decline into winter. Let that settle for a moment. Every achievement of human civilization, every empire, every discovery, every work of art, every scientific breakthrough, all of it has happened while the universe was getting smaller. Not smaller in any absolute sense, of course. The cosmos continues to expand. The distance between galaxies continues to grow, but smaller in the only sense that matters for an observer, the fraction of that expanding cosmos that we can touch, that we can explore, that we can know. And the acceleration is accelerating. This is one of the strangest features of a universe dominated by dark energy. As space expands, there is more space to contain dark energy. Dark energy has the peculiar property that its density remains constant even as space grows. More space means more total dark energy, which means faster expansion, which means still more space, which means still more dark energy. It is a feedback loop with no off switch, a runaway process that will continue until the heat death of the cosmos trillions of years from now. In the near term, the effects are subtle. The acceleration adds perhaps a few hundred kilometers per second per megaparsec to the expansion rate each billion years. That sounds small. In human terms, it is small. but stretched across cosmic distances and cosmic timescales, it compounds. Galaxies that are receding at 50,000 kilometers per second today will be receding faster a billion years from now. Galaxies at the edge of accessibility will slip beyond it. The shrinkage will continue, and there is no ceiling on the expansion. Dark energy does not tire. Dark energy does not run out. In every model we have that explains the observations, dark energy continues to drive acceleration forever, pushing the cosmic event horizon inward, isolating every gravitationally bound structure in its own private bubble of shrinking accessibility, until each island universe contains nothing but the dead remnants of its own collapsed galaxies, surrounded by an infinite emptiness that no signal can ever cross. That is where the cosmos is heading. That is the destination coded into the current laws of physics, the inevitable endpoint of a universe in which dark energy has taken control. We are not merely watching the universe expand. We are watching it tear itself apart, not violently, not dramatically, but quietly, persistently, with infinite patience and absolute certainty. But we are not there yet. We have time. Not infinite time, but time. And the question that presses on us now is what to do with it. What can any civilization do when it realizes that the cosmos is fragmenting, that the accessible universe is shrinking, that the window for exploration and contact is slowly closing? What choices remain? One choice is despair. We could look at the numbers, accept that 94% of the observable universe is already lost, acknowledge that most of what remains will eventually be lost as well, and conclude that cosmic exploration is pointless. Why build interstellar ships when the stars we could reach are fewer every year? Why search for signals when the civilizations that sent them are crossing the horizon? Why invest in the future when the future is one of inevitable isolation? This is a reasonable response. It is also, I suspect, the wrong one, because despair is a luxury the cosmos does not grant. Despair assumes that meaning comes from permanence, that a project is worthwhile only if it lasts forever, that a connection matters only if it cannot be severed. But nothing in the universe works that way. Stars burn out, galaxies collide, black holes evaporate, everything ends. The question has never been whether things last. The question has always been what we do with the time they do, and we have time. We have possibly billions of years before the local group becomes the only game in town. Within that window, the reachable universe still contains hundreds of billions of stars. Even if most of those stars have no habitable planets, even if most habitable planets have no life, even if most life never develops intelligence, even then the numbers leave room for multitudes. We could fill the local group with the children of Earth. We could seed 100 billion worlds with minds that remember where they came from, with cultures that carry the knowledge and values of this brief cosmic moment forward into the long night ahead. We could do this. The physics does not forbid it. The distances are vast, the timescales are long, but the speed of light is fast enough to span the local group many times over before the horizon closes. A civilization that took seriously its position in cosmic history, a civilization that understood it was living in the last era of accessibility, could spread across every reachable star, build monuments that last until the stars themselves die, encode its memory in structures that persist for trillions of years. It could become, in essence, the local group itself, a single, vast organism of intelligence, distributed across thousands of galaxies, surviving and remembering long after every other cluster has vanished behind the horizon. This is not fantasy. This is engineering deferred. The technologies do not yet exist, but they do not violate any known law of physics. We already know, in principle, how to accelerate spacecraft to a significant fraction of the speed of light. We already know how to communicate across interstellar distances. We already know how to preserve information for timescales far beyond a human lifetime. The gaps in our knowledge are technical, not fundamental. They are problems to be solved, not barriers to be accepted. And the alternative is to sit here, on this one small world, in this one brief moment, and let the cosmos shrink around us until nothing remains but a handful of dying galaxies and a memory of how much more there used to be. That is not a fate worthy of a species that has already walked on another world, that has already sent probes beyond the heliopause, that has already detected the faint whispers of gravitational waves rippling through the fabric of space. We are capable of more than that. We are capable of responding to the cosmic situation with something other than resignation. But this requires a shift in how we think about time and purpose and the relationship between the two. It requires acknowledging that we are not building for eternity. Eternity is not available. But that we are building for duration, for persistence, for the longest possible continuation of minds and meaning in a universe that will one day contain neither. It requires understanding that every decade we wait, every century we delay, every millennium we spend arguing about whether to act. Those delays carry a cost measured not in years, but in galaxies. Each postponement means fewer stars to reach, fewer possible neighbours to find, fewer options for the descendants who will inherit whatever we leave behind. The cosmic event horizon is not a wall that will stop us. It is a wall that is already here, already closing in, already shrinking the playing field. We cannot push it back. We cannot stop its advance. We can only race to fill the space that remains before it contracts beyond our reach. And here is where the strangeness of our moment becomes most acute. We are, as far as we know, the only minds in the accessible universe contemplating this situation. We may be wrong about that. There may be civilizations far older and wiser than ours, civilizations that realized billions of years ago what dark energy meant for the future, civilizations that have already begun the great project of spreading across every reachable star. But we have no evidence of them. The sky is silent. The radio spectrum carries no signals. The infrared surveys reveal no megastructures. Either those civilizations do not exist, or they are so far away that their light has not reached us, or they have chosen to remain invisible for reasons we cannot fathom. Whatever the explanation, the practical result is the same. We are alone with the knowledge. We are alone with the burden. We are the only ones, as far as we can tell, who understand that the universe is fragmenting and that the fragments are drifting into permanent isolation. If anyone is going to respond to that situation, it may have to be us. This is a terrifying responsibility. It is also perhaps a privilege. Of all the generations that have ever lived on this planet, we are the first to understand the cosmic situation. We are the first to know that the window is closing, that the opportunities are finite, that the accessible universe is a diminishing resource that will never be replenished. Every generation before us lived in ignorance. Every generation after us will live with the consequences of what we do or fail to do. We are the hinge. We are the point of decision. The cosmos has placed us here at this precise moment in its 14 billion year history and asked us, what will you do with the time you have? I do not know the answer. I suspect no one does. The question is too large, the stakes too high, the uncertainties too vast for any single mind or any single generation to resolve. But I know that the question must be asked. I know that ignoring it is itself an answer and not a good one. I know that the default trajectory, the trajectory where we argue and delay and focus only on the immediate, is a trajectory toward isolation, toward a future where our descendants look out at an empty sky and wonder why their ancestors did not do more when more was still possible. The expansion continues. The horizon shrinks. And somewhere out there, 160 billion stars are crossing beyond reach this year alone, carrying with them whatever worlds they harbour, whatever possibilities they represent, whatever futures they might have offered. Each one is a door closing. Each one is an opportunity lost. Each one is a reminder that the cosmos does not wait, that time is not infinite, that the window through which we can act is neither as wide nor as permanent as we might have wished. We are alive at the only moment when action is both possible and meaningful. The universe has given us a gift, the gift of arriving early enough to see the cosmos in its connected splendour, to understand what is happening, to perhaps do something about it. Whether we use that gift or squander it, whether we rise to meet the cosmic situation or sink beneath its weight, that is the question that will define not just our civilization, but perhaps all civilization, everywhere for all time. Because if we fail, if the sky goes silent and the stars go dark and the local group contracts into its final lonely isolation, there may be no one left to try again. We may be the only chance the universe has to be known, to be explored, to be filled with minds that understand and remember and care. And that chance is slipping away, one galaxy at a time, one star at a time, one moment at a time. The darkness between galaxies is not empty. It is filled with something, and that something is the engine of our isolation. For most of human history, we assumed the universe was static. The stars hung in their positions, the heavens turned in their eternal cycles, and the cosmos was a stage that simply existed, unchanging, permanent, indifferent to time. Even Einstein, when he first applied his equations of general relativity to the universe as a whole, was so disturbed by what they predicted that he added a fudge factor, a cosmological constant, to force the equations to describe a universe that neither expanded nor contracted. He wanted stillness. He wanted permanence. He wanted the cosmos to behave the way his intuition told him it should. He was wrong, and the way he was wrong has shaped everything we have discussed tonight. In 1929, Edwin Hubble sat at the eyepiece of the 100-inch Hooker telescope on Mount Wilson and noticed something that would shatter the static cosmos forever. The light from distant galaxies was redshifted, stretched toward longer wavelengths, and the amount of stretching correlated with distance. The farther away a galaxy was, the faster it appeared to be receding from us. Hubble had discovered what the equations had predicted. The universe is expanding. Space itself is stretching, carrying galaxies apart like raisins in a rising loaf of bread. Einstein called the cosmological constant the greatest blunder of his career. He removed it from his equations, grateful to be free of the arbitrary adjustment, relieved that the universe had turned out to be dynamic rather than static. The cosmos was expanding, and that expansion had been ongoing since the beginning, since the Big Bang, that initial moment of infinite density from which everything emerged. But the story does not end there. It does not end with a simple expansion that gradually slows under the pull of gravity, eventually halting or even reversing as all the matter in the universe tugs everything back together. That was the expected outcome. That was what most cosmologists assumed through the middle decades of the 20th century. The universe was expanding, yes, but gravity would eventually win. The expansion would decelerate. Given enough time, the cosmos might collapse back into itself, ending in a big crunch that mirrored the Big Bang in reverse. In 1998, two teams of astronomers set out to measure the rate of that deceleration. They were studying a particular type of stellar explosion called a Type Ia supernova, the thermonuclear detonation of a white dwarf star that has accreted too much material from a companion. These explosions are remarkably consistent in their intrinsic brightness, which makes them excellent distance markers. By comparing the observed brightness of a Type Ia supernova with its known intrinsic brightness, astronomers can calculate how far away it is, and by measuring the redshift of the host galaxy, they can calculate how fast the universe was expanding when that light was emitted. The two teams, the Supernova Cosmology Project and the High Z Supernova Search Team, expected to find that distant supernovae were brighter than they should be if the expansion were constant. That would indicate deceleration, the slowing of cosmic expansion under the cumulative gravitational pull of all the matter in the universe. It would confirm that the cosmos was behaving as expected, that gravity was winning the long game, that the expansion was a temporary phase that would eventually end. They found the opposite. The distant supernovae were dimmer than expected. Not brighter, dimmer. Fainter than they should have been if the expansion were constant, and far fainter than they should have been if the expansion was slowing down. The only explanation that fit the data was that the expansion of the universe is not decelerating at all. It is accelerating. The cosmos is flying apart faster and faster with each passing moment, driven by some unknown force that overwhelms gravity on the larger scales. The researchers checked their data. They checked their instruments. They checked their assumptions. They looked for errors in the photometry, contamination in the sample, systematic biases in the selection of supernovae. They found nothing. The result held. The universe is accelerating, and it has been accelerating for roughly the past 5 billion years. This discovery earned Saul Perlmutter, Brian Schmidt, and Adam Rees the Nobel Prize in Physics in 2011. But the prize came with a confession. Nobody understands what is driving the acceleration. The force responsible has been given a name as a dark energy, but the name is a placeholder for ignorance. It describes a phenomenon, not a mechanism. It labels a mystery without solving it. Let that settle for a moment. The dominant component of the universe, the thing that determines how the cosmos evolves on the largest scales, the engine that is driving galaxies beyond our horizon and sealing off most of existence from our reach, is something we do not understand. We do not know what it is. We do not know why it exists. We do not know whether it will continue at its current strength, increase, or eventually fade. We only know that it is there, that its effects are measurable, and that those effects are reshaping the future of the cosmos in ways we cannot control. Dark energy makes up roughly 68% of the total energy content of the universe. Ordinary matter, the atoms that make up stars, planets, living creatures, everything we can see and touch and measure directly, accounts for less than 5%. Dark matter, the invisible gravitational scaffolding that holds galaxies together, makes up about 27%. That means we understand less than a 20th of the universe's composition, and the thing we understand least is the thing that dominates everything else. The cosmological constant that Einstein invented and then abandoned has returned, in a sense. It provides one possible explanation for dark energy, a constant energy density inherent to space itself, a pressure that exists everywhere and every when, pushing outward even in the complete absence of matter. If the cosmological constant is real, then empty space has a positive energy, and that energy acts as a kind of anti-gravity on cosmic scales. The more space there is, the more of this energy there is, and since the expansion of the universe creates more space, the outward pressure grows even as the galaxies fly apart. This is the scenario we are living in. This is the default model of modern cosmology, the LCDM model, where L represents the cosmological constant and CDM stands for cold dark matter. It fits the data. It explains the supernova observations, the cosmic microwave background, the large-scale distribution of galaxies, the growth of structure over cosmic time. It works. But it works without explaining why. The cosmological constant has the value it does without telling us what dark energy actually is, without giving us any handle on whether the situation might change in the future. And the implications of the model are what we have been grappling with all night. If the expansion continues to accelerate, then galaxies beyond a certain distance are not merely receding, they are being carried away faster than light can bridge the gap. Not because they are violating relativity, but because space itself is stretching at a rate that exceeds the speed of light. The fabric of the cosmos is the thing moving, and there is no cosmic speed limit on how fast fabric can stretch. Picture a treadmill, a long one, so long you cannot see the end. You're walking forward at a constant pace. The speed of light, let us say, the maximum velocity any signal or object can achieve. The surface of the treadmill is moving backward. At first, the treadmill is moving slowly enough that your forward progress is faster than its backward pull. You're gaining ground. The far end of the treadmill is getting closer, even if slowly. But now imagine that the treadmill begins to speed up. The belt accelerates. At first you're still gaining ground, but more slowly. Then the belt matches your pace, and you're running in place, making no progress at all. Then the belt speeds up further, and now, despite walking forward at the maximum possible speed, you're actually moving backward relative to the floor beneath the treadmill. The far end is getting farther away. No matter how fast you walk, no matter how long you persist, you will never reach it. The treadmill has won. This is what is happening to light in an accelerating universe. Photons leave distant galaxies and begin their journey toward us at the speed of light. But the space between those galaxies and us is stretching, and it is stretching faster than the photons can traverse it. For galaxies close enough, the photons still make progress. The stretching is slower than their speed, and they eventually arrive. But for galaxies beyond a certain distance, the stretching wins. The photons are walking on a treadmill that is accelerating beneath them, and they are losing ground. They will never reach us. The information they carry is sealed away forever. The boundary where this happens is called the cosmic event horizon. It is not a physical surface, not a wall, not a barrier you could touch. It is a mathematical limit, a consequence of the geometry of expanding space-time. Anything beyond the cosmic event horizon is causally disconnected from us. No signal it sends will ever arrive. No light it emits will ever be seen. No influence it exerts will ever be felt. It exists, but it exists in a realm that is, for all practical purposes, a separate universe. The cosmic event horizon today sits at about 16 billion light-years from Earth, though the exact value depends on the model and the measurements. Galaxies at that distance are receding from us at precisely the speed of light, thanks to the expansion of space. Galaxies beyond that distance are receding faster, and we will never receive any signal they emit from this moment forward. But here is the part that twists the knife. We can still see galaxies that are currently beyond the cosmic event horizon. The light we are receiving from them was emitted billions of years ago, when they were closer, when the expansion had not yet carried them past the horizon. We are seeing their past, not their present. The light reaching our telescopes tonight is old light, ancient light, light that left its source when the universe was younger and smaller and more connected. The galaxies themselves have long since crossed the threshold. We are watching ghosts. The Hubble Deep Field and its successors show us galaxies that were relatively close when their light was emitted, but the expansion has been carrying them away all this time. Many of those galaxies are now tens of billions of light years from Earth. The light we see tells us nothing about their present state because that information cannot reach us. We know what they looked like 13 billion years ago. What they look like now, whether they still exist in recognizable form, whether they have merged with other galaxies or collapsed into black holes or given rise to civilizations that wander about us. None of that information will ever arrive. The connection has been severed, and the severance continues. Every moment the cosmic event horizon creeps inward in a practical sense. More galaxies cross it. More stars disappear behind the veil. The 160 billion stars that slip beyond the horizon each year are not exploding or vanishing. They are simply drifting out of our causal reach. They continue to exist, to burn, to perhaps warm planets and foster life. But whatever happens, there will never be known here. Whatever they do will never affect us. They are gone in the only way that matters to observers like us. The universe is fragmenting, but the fragments are not pieces of matter. They are pieces of causality. The cosmos is breaking into regions that cannot communicate with each other, cannot influence each other, cannot even know each other exists. Dark energy is the agent of this fragmentation, and its work is inexorable. There is a haunting irony in this. Dark energy is not destroying the universe. It is not ending existence. It is not even slowing down the processes of stellar evolution, planetary formation, or the possibility of life. All of those things continue, potentially forever, in countless galaxies scattered across the expanding cosmos. The stars keep burning. The planets keep orbiting. Life, wherever it exists, keeps struggling and adapting and perhaps wondering about its place in the scheme of things. But those processes are happening in isolation. The cosmic web is stretching until its strands snap, and once they snap, the regions they connected become separate forever. A galaxy in one region might develop a civilization that masters physics and engineering and philosophy, that builds telescopes and spacecraft and artificial intelligences, and that civilization will never know about a similar civilization in another region, because the regions cannot communicate. Each fragment of the cosmos becomes a universe unto itself, sealed away from all the others by the expansion of space. We are watching this fragmentation happen. We are living through the era when the universe is still connected enough for us to see the process, to measure it, to understand what is being lost. Future observers, billions of years from now, will inherit a cosmos that has already finished fragmenting. They will look out at a sky that contains only the local group, and they will have no way of knowing that other galaxies ever existed. The evidence will be gone. The light will have faded. The cosmic microwave background itself will have stretched beyond detection, its wavelengths so elongated that no instrument could pick them up. The history of the Big Bang, the history of cosmic expansion, the history of the broader universe beyond their gravitational island, all of it will be erased. This is perhaps the strangest consequence of dark energy. Not that it ends the universe, but that it ends the universe's ability to know itself. The cosmos in its old age will forget. It will lose access to its own history. The evidence of the Big Bang, the formation of the first galaxies, the great tapestry of billions of galaxies stretching across billions of light years, all of it will become invisible, undetectable, irrecoverable. Future scientists will look at the data available to them and conclude, reasonably and correctly based on that data, that the universe is static, eternal, and consists of a single galaxy surrounded by endless darkness. They will not be stupid. They will not be careless. They will simply be working with a biased sample, a universe that has hidden its origins from them. The expansion is erasing the cosmic record. It is closing the archives. It is pulling the library shelves into the dark. We happen to exist at the moment when the archive is still open. We can still read the early chapters. We can still see the cosmic microwave background, the fossil radiation from the Big Bang, the oldest light in the universe. We can still map the distribution of galaxies and deduce the physics of the first moments. We can still watch dark energy at work, measuring its effects on supernovae and the growth of structure. We have access to data that our distant descendants will not have, and we are beginning to understand what it means. This is the privilege of the present. This is what makes our moment in cosmic history unique, unrepeatable, and precious. We are the observers who can see both the beginning and the slow ending, the witnesses to a cosmos that is still revealing itself, even as it prepares to go silent. The numbers bear repeating. 94% of the observable universe is already beyond our reach. The accessible fraction shrinks with every passing moment. The local group, roughly 50 galaxies, dominated by the Milky Way and Andromeda, will merge over the next several billion years into a single giant elliptical galaxy, sometimes called Milkdromeda by astronomers with a taste for wordplay. That galaxy will be our final home. Everything else will have retreated into the darkness, redshifted into invisibility, separated from us by distances that light itself cannot bridge. And here is the final twist, the part that makes the whole situation feel almost personal, almost deliberate, though it is neither. The expansion of the universe is driven by dark energy, and dark energy is the same everywhere. It is not concentrated in some regions and absent in others. It pervades all of space, uniformly, constantly, relentlessly. The same force that is pushing distant galaxies away from us is pushing every other observer away from every other galaxy. The fragmentation is happening everywhere, to everyone, all at once. If there are other civilizations out there, in galaxies beyond our local group, they are facing the same situation. They are watching their own horizons shrink. They are seeing their own skies empty. They are grappling with their own versions of this realization, in their own languages, with their own cosmologies, and reaching the same inescapable conclusion. The universe is coming apart, and there is nothing to be done about it. Perhaps they are handling it better than we are. Perhaps they have made peace with cosmic isolation, accepted it as a natural feature of existence, moved on to other concerns. Perhaps they are focused on local pleasures and local projects, on the billions of stars that will remain accessible even after the horizon shrinks, on the lifetimes of meaning that can be built without reaching for the unreachable. Or perhaps they are like us, troubled by the knowledge, restless with the questions, unable to fully accept that most of reality is already gone. Perhaps they too lie awake at night, or whatever passes for night on their world, wondering what lies beyond the horizon, mourning galaxies they will never visit, yearning for a connection that physics has made impossible. Dark energy does not care. The cosmological constant, if that is what it is, has no opinion on the matter. It is not malicious. It is not even indifferent in any meaningful sense, because indifference implies the capacity to care. It is simply a property of the universe, a feature of the fabric, a number in the equations that happens to have a particular value. A slightly different value, and the expansion would have decelerated, galaxies would have remained reachable, the cosmic library would have stayed open forever. A slightly different value in the other direction, and the expansion would have torn apart galaxies, stars, planets, atoms. The big rip, the scenario where dark energy grows stronger over time and eventually shreds all structure. We live in the middle, in a universe where the expansion is strong enough to isolate but not strong enough to destroy. It is a peculiar kind of mercy. We get to keep our local group. We get to retain the gravitational island that holds Andromeda and the Milky Way, and a few dozen smaller galaxies in a permanent embrace. We will never be truly alone, not in the sense of floating in absolute emptiness. There will always be stars overhead, always be galaxies to explore, always be matter and energy and possibility within reach. But the rest of the cosmos, the overwhelming majority of it, is slipping away. The campfires are dimming, one by one, receding into the night. The other islands are drifting beyond the horizon, their lights fading, their stories ending. We are being left behind, and so is everyone else, each group on its own gravitational raft, each raft floating in a separate ocean of darkness that grows deeper and wider, with every passing moment. The universe is not dying, but it is dissolving, coming apart at the seams, fragmenting into pieces that will never touch again. And we are here, at the moment of dissolution, with eyes to see and minds to understand, watching the cosmos we love prepare to say goodbye. Let that weight settle for a moment. Let the full measure of what we have been discussing find its place in your understanding. We are not speaking of distant threats or hypothetical futures. We are speaking of a process that is happening right now, in this instant, as you listen to these words. Galaxies are crossing the cosmic event horizon. Stars are winking out of our causal future. The accessible universe is shrinking, has been shrinking since dark energy took the reins roughly 6 billion years ago, and will continue shrinking for as long as the laws of physics remain what they are. And yet we are here. This is the part of the story that deserves its own moment of contemplation. Not the loss, not the isolation, not the relentless mathematics of recession, but the simple, staggering fact of our presence at this particular instant in cosmic time. Think about what it took for you to exist. Think about the chain of events, the improbable sequence of cosmic accidents that led to this moment where a collection of atoms arranged in the pattern of a human being can lie in a dark room and contemplate the fate of the universe. The first stars had to form from primordial hydrogen, burn through their nuclear fuel and explode, scattering heavier elements into the void. Those elements had to coalesce into second-generation stars with rocky planets. On at least one of those planets, chemistry had to become biology. Single cells had to become multicellular organisms. Life had to crawl out of the sea, develop spines and brains and opposable thumbs, learn to make tools and language and abstract thought. Civilizations had to rise and fall, knowledge had to accumulate, telescopes had to be invented, equations had to be written, satellites had to be launched. And somewhere in the middle of all of that improbability, you had to be born. Had to develop the curiosity to wonder about the night sky, had to find yourself here, now, listening to a story about the end of cosmic visibility. The odds against any particular consciousness existing are beyond calculation, and the odds against that consciousness existing at precisely this moment in cosmic history, the moment when the universe is still rich with light, still full of visible galaxies, still telling its story to anyone with eyes to receive it, are even more staggering. We are not here at the beginning when the cosmos was a featureless plasma and there was nothing to see. We are not here at the end when the sky will be black and empty and the evidence of other galaxies will be erased. We are here in the middle, in the window, in the brief cosmic afternoon when the lights are on and the library is open and the story is still being written on the sky. Think about what that means. If you had been born 10 billion years ago, you would have lived in a universe where the expansion was still decelerating, where gravity was winning, where the cosmic horizon was actually growing. But you would have lived before life on Earth had evolved beyond single-celled organisms. There would have been no eyes to see the galaxies, no minds to contemplate their distances, no hands to build telescopes or write equations. The universe would have been more accessible, but there would have been no one to access it. If you had been born 100 billion years from now, you might have been born into a civilization with technologies we cannot imagine, with knowledge accumulated over eons, with capabilities that would seem like magic to us. But you would have been born into a universe where the evidence is gone. The other galaxies would have redshifted beyond detection. The cosmic microwave background would have stretched to wavelengths too long to measure. The sky would be dark and the universe would appear to contain nothing but the merged remnant of the local group, a single aging galaxy floating in absolute emptiness with no hint that anything else had ever existed. You were born now. You were born in the window. You were born at the moment when the universe is still visible, when the story is still being told, when the evidence is still streaming down from the sky in the form of photons that left distant galaxies billions of years ago. You were born at the moment when we can still see the cosmic microwave background, can still detect the echoes of the Big Bang, can still measure the acceleration of expansion and deduce the existence of dark energy. You were born at the moment when the cosmic library is still open, when the books are still on the shelves, when the knowledge is still there for the taking. This is not a coincidence that we can explain. It is not a mystery that has a tidy solution. It is simply a fact, a brute fact, a feature of your existence that sits somewhere between luck and providence and pure mathematical contingency. You are here now. The universe is visible now. The two facts overlap, and that overlap is the window through which you are peering at the cosmos. Stop and feel the weight of that. You're looking through a window that is closing. You're reading a book that is being erased. You're listening to a story that is fading into silence. and you are one of the vanishingly few beings in all of cosmic history who will ever have the chance to do so. This is the privilege. This is the strange, haunting, beautiful privilege of existing in the cosmic afternoon. We are not the first to exist, and we will not be the last. But we may be among the few who will ever know how big the universe really is, how many galaxies it really contains, how ancient and how violent and how improbable the story of existence really was. We are the witnesses. We are the ones who happened to be awake when the lights were still on. And here is the question that haunts me, the question that I cannot answer, the question that perhaps cannot be answered at all. What do we do with this knowledge? We cannot stop the expansion. We cannot reach the receding galaxies. We cannot reverse the process or slow it down or negotiate with dark energy for more time. The physics is the physics. The universe does not take requests. But we can do something. We can look. We can measure. We can record. We can build instruments that capture the light of distant galaxies and store the information in forms that might survive. We can write down what we have learned, encode it in every medium we can imagine, pass it on to our descendants with the explicit instruction: this is what the universe looked like when we could still see it. This is what existed. This is what was real. We are cosmic archivists. We are the scribes of a library that is being closed. Every measurement we take, every image we capture, every equation we derive is a kind of preservation, a rescue operation conducted against the erasure of cosmic memory. The galaxies beyond the horizon will never be reachable, but they do not have to be forgotten. Their light reached us once. Their photons struck our detectors. The information they carried is still here, stored in databases and papers and the hard drives of observatories around the world. It is not much. It is a fraction of what exists out there. But it is something. It is our portion. It is the inheritance we received from a universe that was once connected and is now coming apart. Perhaps future civilizations will look back at our era as a kind of golden age, not because we were wise or powerful or technologically advanced. By their standards, we will seem primitive beyond imagining, but because we could see, because we lived in the window, because we had access to evidence that they will never have, knowledge that they will never be able to recover, a picture of the cosmos that they will have to take on faith because the original has faded to black. What will they think of us? What will they make of our fragmentary records, our imperfect measurements, our attempts to describe in words and equations a universe that was still revealing itself to anyone who cared to look? Will they be grateful? Will they be curious? Or will they simply not believe us, concluding that our claims of a universe filled with 2 trillion galaxies were myths or exaggerations or errors of calibration? It is possible that the truth will be lost. It is possible that the isolation will be so complete, the erasure so total, that future beings will have no way of knowing what once existed. They will look up at a sky containing a single aging galaxy and assume that this is all there is, all there ever was, all there ever will be. The cosmic horizon will have swallowed the evidence. Dark energy will have erased the story, and the universe's great autobiography will end with a lie. Not a deliberate lie, but a lie of omission, a lie of physics, a lie that says, you are alone. You have always been alone. There is nothing beyond what you can see, unless we prevent it, unless we pass the knowledge down so carefully, so deliberately, so persistently, that it survives the long forgetting, unless we become the ancestors who refuse to let the truth die. This is not a task for governments or institutions. It is a task for the species. It is a task that will take billions of years if it is to succeed, a relay race of memory passed from generation to generation, from civilization to civilization, from one form of intelligence to whatever form comes next. It is perhaps the longest-term project that any beings have ever contemplated, and it may also be the most important. The preservation of cosmic context, the maintenance of perspective, the refusal to let the universe forget what it once contained. We do not know if we will succeed. We do not even know if we will survive long enough to try in any meaningful way. The timescales are so vast, the uncertainties so profound, that any confidence would be foolish. But the task exists. The task is real. And in some small way, this very moment, you, lying in the dark, listening to these words, contemplating the fate of the cosmos, is part of that task. You are receiving the knowledge. You're participating in the transmission. You're one of the links in a chain that may or may not hold, one of the scribes in a library that may or may not survive, one of the witnesses whose testimony may or may not be believed by beings who will never see what you have seen. It is not nothing. It is not much, but it is not nothing. And perhaps that is the proper response to cosmic isolation. Not despair, not resignation, not the paralysis that comes from confronting scales so vast that individual action seems meaningless, but the quiet determination to do what can be done, to record what can be recorded, to remember what deserves to be remembered. The universe is coming apart. We cannot stop it, but we can bear witness. We can testify. We can leave a record that says, the cosmos was once connected. The lights were once on. We were there. We saw it. And we did not forget. There is one more thing I want to say before we come to the end of this long journey together. It is something that the physics does not tell us, something that the equations do not address, something that emerges only when you step back from the mathematics and ask what it all means for the experience of being alive. The universe that is disappearing beyond the cosmic horizon, those 94% of galaxies that are already unreachable, those 160 billion stars that slip away every year, they are not diminished by their inaccessibility. Their beauty is not lessened by the fact that we cannot visit them. Their existence is not negated by the fact that we will never know their stories. They are out there, right now, doing whatever galaxies do, forming stars, nurturing planets, perhaps hosting civilizations of their own. They are real. They are present. They are part of the cosmos even if they are no longer part of our cosmos. We have a tendency, we humans, to measure value by accessibility. If we cannot reach something, touch it, study it, possess it in some way, we are tempted to conclude that it does not matter. This is a bias of our evolutionary heritage, shaped by millions of years of survival in environments where only the local and the immediate could affect our prospects. But it is not a truth. It is not a feature of reality. It is a feature of our psychology, and we can transcend it. The galaxies beyond the horizon matter. They matter not because they are useful to us, not because they will ever contribute to our well-being, not because we will ever receive any benefit from their existence. They matter because they are there. They matter because existence itself is the measure of value, and they exist. They are part of the tapestry, part of the story, part of the vast unfolding of possibility that began with the Big Bang and will continue long after our sun has cooled to a white dwarf, and then to a black dwarf, and then to something colder still. We are not the centre. We are not the point. We are not the protagonists of a story that exists for our benefit. We are participants in something vastly larger than ourselves, something that includes us but does not depend on us, something that would go on even if we had never existed and will go on long after we are gone. The universe does not need witnesses. It does not need archivists. It does not need beings who lie awake at night worrying about cosmic isolation. It simply is, in all its terror and glory, and it would be just as real if no one were here to see it. But we are here, and because we are here, we have the privilege of seeing it. We have the privilege of understanding, at least in part, what is happening and why. We have the privilege of feeling the vertigo, the awe, the grief, the wonder. We have the privilege of being conscious in a cosmos that, as far as we know, has very little consciousness to go around. Do you understand how strange that is? Do you feel the weight of that improbability? In a universe that is overwhelmingly composed of hydrogen gas and empty space, of dark matter and dark energy, of forces and fields that have no preferences and no opinions. In that universe, there is a pocket of matter that has arranged itself into patterns capable of contemplating the whole. There is a configuration of atoms that can lie in a dark room and think about galaxies. There is a process of chemistry and electricity, and whatever consciousness is that can reach across billions of light years with its understanding and touch. However briefly, however incompletely, the structure of the cosmos itself, you are that process. You are that pocket. You are that improbability made flesh, and you are doing right now what nothing else in the observable universe, as far as we know, can do. You're thinking about what it means to exist. The campfires are dimming. The other islands are drifting away. The ocean of darkness is growing wider and deeper with every passing moment. But here, on this island, on this raft of light and matter that we call the local group, there is a fire that is still burning. There are minds that are still wondering. There are hearts, or whatever the aliens have instead of hearts, that are still capable of feeling the strange mixture of grief and gratitude that comes from understanding both the loss and the gift. We are here at the moment of dissolution. We are here as the universe prepares to say goodbye. And there is no one else to mark the occasion, no one else to feel the enormity of what is being lost, no one else to say, "This matters. This meant something. This was beautiful and terrible and worth having seen." So let me say it now, for whatever it is worth, for however far these words might travel, for whoever might hear them in the vast stretches of time that lie ahead. The universe was once connected. The lights were once on. 2 trillion galaxies shone in the darkness, each one a city of stars, each one a story that we will never fully know. They are receding now, fading, crossing the horizon one by one. Most of them are already gone. Most of reality is already out of reach. But we saw them. We measured their light. We calculated their distances. We traced their histories back to the hot, dense beginning and forward to the cold, dark end. We understood, at least in outline, the shape of the cosmos and the forces that govern it. We held the whole picture in our minds, however briefly, however imperfectly. And now the picture is fading. The evidence is disappearing. The story is ending, at least for us. Look up at the night sky one more time. Look at the stars scattered across the darkness, the faint smudges of galaxies visible to your unaided eye, the Milky Way arching overhead if you are lucky enough to be somewhere dark. This is what remains. This is what we can still touch. This is the portion of the cosmos that gravity has chosen to keep. The gravitational island that will never drift away. The inheritance that dark energy has not yet claimed. It is enough. It is more than enough. It is billions of stars and potentially billions of worlds. An eternity of exploration for any civilization patient enough to undertake it. The local group is not small by any human measure. It is only small compared to what we have lost. But we know what we have lost. That is the difference. That is what separates us from the beings who will come after. The beings who will live in a universe that appears to contain only one galaxy. Who will have no evidence of cosmic expansion. No reason to suspect that anything lies beyond the endless dark. We know. We remember. And perhaps that memory is its own kind of treasure. Its own reason for existing. Its own answer to the question of what it all meant. The universe is not dying. But it is dissolving. It is coming apart at the seams, fragmenting into pieces that will never touch again. And we are here, in the space between the beginning and the end, with eyes to see and minds to understand, watching the cosmos we love prepare to say goodbye. The other campfires are fading into the night. The other islands are disappearing over the horizon. The ocean of darkness grows wider with every breath you take. But this fire is still burning. This island is still here. And you are still awake, still listening, still wondering what it all means. Perhaps that is enough. Perhaps that has always been enough. Perhaps the meaning was never in the reaching but in the seeing, never in the arrival but in the journey, never in the possession but in the love. The universe gave us a window, it gave us a moment, it gave us light that travelled billions of years just to land on the back of your eye and become a thought. What more could we have asked for? The window is closing now. The moment is passing. The light that is still arriving is the last light that will ever arrive from those distant shores. But it arrived. It found us. It told us its story. And we heard it. Settle into the silence now. Let the weight of the cosmos rest gently on your chest. The galaxies beyond the horizon are still out there, still shining, still real, just unreachable, just beyond the edge of what physics allows us to touch. They are not nothing. They are not nowhere. They are simply elsewhere, forever elsewhere, and we are here, awake, for a little while longer, in a universe that was once connected and still remembers what connection felt like. The fires burn in absolute solitude, but so for now do we.